Okay, I'm going to do one more proof here for you because I think this one you're probably going to find very confusing. This is number 4, first one on the back side of your worksheet. So if you're confused on that one, take a look. We might want to redraw our picture for this. The confusing thing is probably that we have nothing about parallel lines in this proof as far as you're given in your proof. We are not given parallel lines, we're given angles congruent, and we're asked to prove angles congruent, and you're looking at triangles. Well, we haven't gotten into triangles, so don't worry, we don't have to use anything about triangles. It really does come down to parallel lines, and it's actually going to be the shortest proof probably that you've done. I know that doesn't make sense right now to you. Let's work through it. So I'm going to start with given information, angle 3 is congruent to angle 6. Whoops, it would help if I was on my pen. And we're asked to prove that angle 1 is congruent to angle 4. So I'm going to propose that the only way that we would know angle 1 is congruent to angle 4, or should I just say a way that we would know that angle 1 is congruent to angle 4, would be if we knew that QP was parallel to RS, because angle 1 and angle 4, if we look at line QP here and line RS, angle 1 and angle 4 are an alternate interior angle pair. So basically, if I redraw those two lines with that transversal QR, angle 1 is right here, that's angle 1, and angle 4 is right there. And if I knew those two lines were parallel, then I could jump to, yes, alternate interior angles are congruent. So, ideal situation would be that I would have QP parallel to RS, or PQ parallel to RS. And again, this is just me making up what I want to be true. If I know this is true, then it follows that angle 1 is congruent to angle 4, and that would be my alternate interior angle theorem. Okay, but I just totally inserted that step, and I don't know if I'm allowed to say that. So I'm going to see, I do know that angle 3 is congruent to angle 6. And if I take a look at those, aren't those also an alternate interior angle pair? Using the same two lines, PQ and RS, but instead of using, so here's my PQ and RS that I'm redrawing, instead of using this transversal QR that I used right here, what if I use transversal PS and I put that right in here? Then I'm creating angle 3 right here and angle 6 right here. And that's another pair of alternate interior angles. So, follow my thinking. If alternate interior angles are congruent, then what do I know about the two lines? Well, yeah, I do know the lines are parallel. So this proof becomes a 3-step proof, because if you read the first two lines together, if angle 3 is congruent to angle 6, then... Okay, my video stopped, so I tried to go back just to finish my thought. If angle 3 is congruent to angle 6, then PQ is parallel to RS, and now I'm proving lines parallel, so I'm using my converse theorem. Alternate interior angle converse theorem. And then if I continue and I read the next two lines together, if PQ is parallel to RS, then angle 1 is congruent to angle 4 by my alternate interior angle theorem. So this is a really good proof, and I just want you to stop a minute and kind of look at the overall. This is a really good proof to make sense of when do I use the converse and when do I not use the converse. Because in step 2, so I'm making this my step 2 and this my step 3. In step 1 up there. But in step 2, I'm proving lines parallel, and then I'm using my converse theorem. When you're making a statement about lines being parallel, you better be using the converse, with the exception of the parallel transitivity theorem. And then in step 3, I'm saying something about angles. So in this case, congruent, usually congruent, but we could also say supplementary because we have a supplementary angle pair. And then I'm using just my regular theorem, no converse. Okay, so just a good one to pick up on that. That was a tough one in terms of the visual. Don't get too freaked out if you couldn't get that one, but hopefully you followed my thinking there.